Jupiter, a place of colossal storms, deadly radiation and captivating beauty. A powerhouse whose mass is so great, it influences even the Sun itself. Jupiter is fast becoming one of the most studied objects in our solar system, with 7 flybys, 2 orbiters with 1 still in operation today, and 2 additional planned missions. There is so much to know about the 5th planet from the Sun. What causes its distinctive red coloration? What is it made of? What lies beneath its obscuring clouds? What do we know about its great red spot? Jupiter holds a vital role in protecting our solar system, and it's time to delve into its mysteries. The 5th planet from the Sun, Jupiter, is found on the outskirts of the asteroid belt, and sits between the orbits of Mars and Saturn. It is 778 million kilometers away from the Sun on average, or $5.20, and completes an orbit every 12 Earth years. The axial tilt of the planet is small, only 3 degrees. This means it doesn't experience much change in seasons, unlike Earth and Mars. And very much like Saturn, its radius at the equator is greater than at the poles. It is a massive planet, the largest in our solar system. It is so massive, its mass is 1/1000th that of our Sun. That might not seem a lot, but once you realize the Sun contains 99.86% of all the mass in the solar system, you'll realize that Jupiter equals almost the remainder. Its mass is 2.5 times that of all the other planets in the solar system combined. And this brings about an interesting phenomenon. The barycenter between Jupiter and the Sun is actually above the surface of the Sun, at 1.068 solar radii from the Sun's center. Let's talk about barycenters. When we think of an object orbiting another object, we don't necessarily think that the smaller object has a gravitational influence on the bigger object. That's because most of the time the effect is negligible, like the ISS orbiting Earth, or even Mercury orbiting the Sun. But it does still happen. A barycenter is the center of mass between these 2 orbiting objects, or the location in space they both orbit around. With Jupiter being the mass and distance from the Sun, it is, unlike Mercury, its effect is far from negligible. As Jupiter swings around the Sun, both of them do a little dance around this center of mass, which is actually above the surface of the Sun. Let me show you this principle with an example. If I get a heavy object and a less heavy object and attach them to the ends of a long stick, in order for the stick to balance, we need to find the center of mass. As you can see, the center of mass is closer to the heavier object. Imagine this is the Sun and Jupiter with the stick being gravity, and you'll understand how a barycenter works. While Jupiter has the greatest mass of any planet in the solar system, it's not the densest. It is the most massive because it is the largest. If Neptune was the same size as Jupiter, it would be the most massive. And if Jupiter was the same size as Earth, Earth would be over 4 times more massive. As it is though, the diameter of Jupiter is 11 times that of Earth, and its total mass is 318 times more than Earth's. As we know, mass affects gravity. This means that Jupiter has a huge gravity, over twice that of Earth at 2.528 g at its surface. The gravity of Jupiter is so influential in the solar system that it affects every planet to 1 degree or another. Its gravity is strong enough to tear asteroids apart and capture 67 moons at least. Some scientists think that Jupiter destroyed many celestial objects in the ancient past, as well as preventing other planets from forming. One example of this in particular is 4 Vesta. Scientists even predict the gravity of Jupiter is so significant around the solar system that it is perturbing Mercury's already eccentric orbit enough that in a few billion years the tiny planet may either crash into the Sun or be ejected from the solar system altogether. At the moment though, it could be the hero of the inner 4 planets. Without Jupiter acting as a cosmic vacuum cleaner, it wouldn't be sucking up dangerous objects like long-period comets, or perturbing their orbits enough to give them a little kick of energy so that they leave the solar system altogether. Jupiter is the 5th planet from the Sun, and it's 5 times further away from the Sun than Earth. Even so, it can be the 3rd brightest object in the night sky, after the Moon and Venus. I just want to show you how bright that is. Just using a handy cam, we can see Jupiter quite easily in the night sky. With a maximum apparent magnitude of -2.94, it can actually cast shadows. As a result of it being so obvious in the sky, it makes a very nice target for amateur astronomers. As consumer telescopes have improved in recent years, it's amazing what details you can see from your back garden. And what makes these famous patterns? The cloud layer is only about 50 kilometers thick and contains ammonia crystals much like on Saturn, but the coloration comes from compounds heating up from deep within Jupiter and then rising. These compounds are known as chromophores, and when they reach the clouds, they interact with the UV light of the Sun to create these spectacular multicolored bands. This is quite the cycle though, and the face of Jupiter can change dramatically over time. Even if their colors do change, the actual latitude of these bands remains consistent enough to be given identifying designations, but they can vary in width over the course of time. Lots of storms and turbulence occur where these bands meet, and it is the reason and engine behind Jupiter's very famous Great Red Spot. The storm is huge. It can easily fit the diameter of Earth within it. It has existed for as long as we've known, since it was first discovered in the 17th century. It might very well be a permanent feature of the planet, but interestingly it has decreased in size since observations began. The reason for its reddish color is unknown, and the color of the spot can vary greatly, from brick red to almost white. The most recent theory for its color is chemical compounds being broken up by the UV light of the sun, much in the same way as the process that happens on the rest of the planet. The storm is actually much higher up in the atmosphere than the surrounding clouds and as a result can interact with the sunlight a lot more. This would explain why its color can be much stronger than anything else around it. But Jupiter doesn't just have one scientifically interesting storm. Another storm, known as Red Spot Jr., formed when three storms merged into one between the years of 1998 and 2000, and it has so far passed unscathed by its bigger neighbor and is now quite a prominent feature of the planet. It could last for another couple of hundred years if it avoids the same fate of a similar storm which passed right through the heart of the Great Red Spot. So, what do we think Jupiter is made of? Well, much like Saturn, under the atmosphere are gaseous, then liquid, and then metallic forms of hydrogen. The further into the planet you go, the greater the pressure becomes. Under immense pressure, hydrogen acts as a metal. And beneath that is an ice or a rocky core. Because we can't recreate on Earth the immense pressures Jupiter experiences, we don't really know what properties these materials have at the core. Roughly 90% of Jupiter is thought to be hydrogen, 10% helium, and then trace amounts of methane, ammonia, and others. Jupiter rotates very fast, faster than any other planet, completing a rotation in only 10 hours. But due to it not being solid, it doesn't rotate the same speed all over, a rotation at the poles taking 5 minutes longer than at the equator. As a child, I was very curious why Jupiter wasn't a star. Considering Jupiter is so massive, plus it is predominantly made of flammable hydrogen, surely someone just needs to throw a match in to set it alight. Well, the sad news for my inner child is that stars don't really work that way, plus there's barely any oxygen on Jupiter to allow for combustion. Stars produce their heat from nuclear fusion caused by the extreme pressures found at a star's core. Current thinking is that Jupiter would need to be roughly 75 times more massive than it is now to be massive enough to be a star. Although interestingly its volume isn't too far off from the smallest known red dwarf. And yes, you may have noticed in this picture, Jupiter does indeed have rings. Nothing on the scale of Saturn, but there are 4 planetary rings. The main ring is very thin but very bright, the rest quite wide but exceptionally faint. The main ring is about 6,500 kilometers wide, and the only distinctive feature you will see is what is known as the Métis notch. Something else to note about Jupiter is its remarkably strong magnetosphere. It is 14 times stronger than Earth's due to the planet's liquid metallic hydrogen center. This makes it the strongest magnetosphere of any planet in the solar system, and it's only beaten by the Sun's sunspots. There are a couple of reasons why this is really interesting. The first is that magnetospheres channel solar wind to the planet's pole which produces magnificent aurorae. The second is that the 4 biggest moons of Jupiter are protected from this solar wind because they orbit within the magnetosphere. This implies that they don't need their own strong magnetospheres because Jupiter is doing that for them. However, this doesn't mean they are safe from radiation. Jupiter has a powerful radiation band around it, the same radiation band that has crippled any probe that went through it. The closest large moon to Jupiter, Io, passes right through the heart of this radiation band, receiving 3,600 rem per day on the surface. For a point of comparison, anyone exposed to this much radiation would be dead within 4 hours. Not the best home away from home, then. When it comes to the Jovian moons, I'll only very quickly talk about them because I have made a separate video about them here. Jupiter has 67 known natural satellites. 51 are under 10 kilometers in diameter, but the largest, the Galilean moons, are some of the biggest in the solar system. They are Io, Europa, Ganymede and Callisto, and they are all interesting in their own right. Ganymede is actually the biggest moon in the solar system and has a greater diameter than that of Mercury. And with this final thought, take a look at Jupiter through the infrared. Demonstrating the immense size and power of this planet, this dot at the bottom of the planet is the impact of an object from space, which if it had hit Earth, could have spelled the end of our planet as we know it. We can be glad Jupiter is there, not only for its beauty, but because in so many ways it is an asset to our solar system. Thank you so much for watching this far. Did you learn something today about Jupiter you never knew before? And what planet remaster would you like to see next on this channel for this series? Let me know in the comments below and I'll see you next time. Thanks for watching. For this video, I particularly want to thank George, Brian and John for their incredible support. Making this video required some long-time planning and work which we were only able to do thanks to the consistency and sustainability of your memberships as astronauts on Patreon. A huge thank you to everyone who has signed up.